Welcome everyone. We're going to take a look at three types of motion problems where objects are meeting one another. This is entirely an optional video. If you'd like to give this problem a try first, I would recommend pausing the video, try to do this, and then I will do it. And I think that's a good way to learn. So here we go. First thing I'm going to do is I'm going to draw a picture. So I'm going to draw Moops. He is running at a velocity of 4. It's positive 4. So I know it's going to the right. 4.4. Towards Meeps. This is Meeps. Meeps is running at negative 6.6. So I know she's going this way because it's negative. And I'm going to zoom in a little bit if I can. There we go. Okay. And they're 15 meters apart. So if we consider Moops at point 0, this distance is 15 meters. And we're looking for, I always want to write down what we're looking for. We're looking for the distance they collide, and we're looking for the time that they're going to collide. So I need to write an equation for both. Both are moving at a constant velocity. So I am going to write this as v equals delta x over delta t. Meeps is also moving at a constant velocity, so I can use the same equation. From here, I'm going to plug in my numbers. So I know Moops is going at 4.4 meters per second. He travels this distance, this unknown distance of x. So I'm just going to call it x, and I don't know what time he's going to reach that distance. So I don't know that, so I just call it t. Meeps is negative 6.6. Her distance is what's left over. So her distance would be 15 minus whatever he ran. However, she is running in the negative direction. So her distance is negative 15 minus x. And the time is the same. If we start the stopwatch when they both start to run, we would stop the stopwatch right when they hit in the middle. So the times are the same. So both t's, the t here and the t here, it's going to be the same number because they're both reaching the middle at the same time. Or maybe not the middle, but they're colliding with each other at the same time. Okay, so from here, I'm going to cross multiply. So I get 4.4t equals x. And on this side, I get negative 6.6t equals minus 15 plus x. And it is a plus x because I am distributing that negative. So I get negative 15, and then negative times negative x is plus x. From here, I am going to substitute this value of x into my x. And I would get negative 6.6t equals minus 15 plus 4.4t. Now I can solve this. So let's subtract 4.4t from both sides. That's going to cancel. I'm going to get negative 15 on this side, and on this side I have negative 2.2t. From here, I'm going to divide both sides by negative 2.2t. The negative 2.2 is going to cancel with the negative 2.2. Oops, not the t, sorry. Let me go back. That shouldn't be there. So the negative 2.2 is canceling both sides. And then I'm left with t equals negative 15 divided by negative 2.2 is 6.82. Awesome, that's one of my answers. And then to get the other one, I'm going to, oops, I wanted red. I'm going to put this right in there. So my x is 4.4 times t. I just found what t was. 6.82, which is equal to, on my calculator, 30.01 meters. I'm going to check my answer. 30 meters is my distance they're going to collide. Where would 30 meters be? 30 meters is going to be way over here. Does that make sense that they're colliding right there? If they're running towards each other, if they're running this way and this way, it doesn't make sense they're going to collide way over here. So I must have did something wrong. Let's take a look. What did I do wrong? Ah, do you see it? I see it. It is right here. So when I subtracted the t's, negative 6.6 minus 4.4 is not negative 2.2. It's negative 11. Negative 11. Okay, so if I have negative, let me erase this. Okay, so now I'm going to divide both sides by negative 11. Cancels. And I get t equals negative 15 divided by 11 is 1.36 as my time. And then I'm going to plug that once again up into my time. And we get 4.4 times 1.36 is 5.98. Okay, let's see if that makes sense. That would be, it's less than halfway. 5.9 is like right here. Does it make sense that it's less than halfway? Yeah, it makes sense. He is running slower. This is faster. So it makes sense that it's going to be on this side and not this side. So that makes sense. So we all make mistakes. I just made a mistake. But the lesson learned here is to check your answer at the end. See if it's possible. If you get an answer like I did that's way out here, then I know that is not possible. I know I did something wrong and I could go back and look. It's also important to, when you're doing your work, to make it kind of nice and neat. If you skip a lot of steps, then there's a chance that if you do make a mistake, it's going to be harder for you to go back into your work and find where you made that mistake. But if you lay everything out nice and neat, it makes it a little bit easier to go back and find that mistake, and you don't have to redo the whole problem over again. Okay, let's move on to number 2. Number 2 is like part 2 for our lab. Moops robbed a bank and is fleeing the scene at 20 meters per second. Meeps leaves 5 seconds later at a velocity of 25 meters per second and chases him to catch him to turn him in. At what displacement and time will she catch him? So we're going to say he starts first. He is running this way at 20 meters per second. She is going to start here going at 25 meters per second, and her time is 5 seconds later. So I'm just going to kind of write that here. 5 seconds later. Okay, and once again, I'm trying to find the displacement and the time. Okay, so I'm going to do the same thing as I did last time. Actually, I'm going to write this 5 seconds up high. So I'm just kind of labeling it. She is 5 seconds later. I'm going to draw an arrow to her. Okay. I'm going to write an equation for both. They are moving at a constant velocity. So both are moving at constant velocities. So I can use this equation for both again. Awesome. And I need to write, okay, so I could plug in the velocities. 25 equals, 20 equals. For the distance, they're going to meet at some point over here in the distance. And the distance they travel is going to be the same because they both started at the bank and they're both ending when she catches him. So the distance for both is the same. So it's different than number one, where number one, they're meeting at this point here, which is not in the middle. In this one, she traveled further and he traveled less because she was going faster. In this one, the distance is the same because they're starting at the bank and they're ending when she tackles him and catches him. So the distance is the same, so I could use x. However, this one, the times are different. So he had a 5-second head start. She was 5 seconds later. So this time, the times are going to be different. So I'm going to put t, when t equals 0, is when this whole thing starts. This whole thing starts, if this is moops, and this is meeps 5 seconds later, he starts at t. So if you think about our cars in the lab, we started the stopwatch when the first one started. So when moops starts running, we're starting the time. So he needs to be at t equals 0. So when t equals 0, he is going. She starts later. So I'm going to put a t for her also, but does she get more time or less time? She has less time to get to this point way over here. She has less time to get there because he was running for 5 seconds more than she was running. So she has less time, so she gets -5. And the reason I'm doing t -5 and the reason I'm not doing t over here and t +5 on this side, which is what a lot of you did on the lab, it's because if you do this, then when t equals 0, when the stopwatch starts, it's when she starts. And when you started, he's already 5 seconds down the road. And so I don't want to do that. I want to start the timer when he starts running. So when t equals 0 is when he starts, and she has 5 seconds less. Okay, so from here, I'm going to cross multiply. I'm going to get 25 times t minus 5 equals x. And on this side, I get 20t equals x. Okay, I am going to distribute. Okay, so I'm going to get 25t minus 25 times 5, which is 125 equals x. And I already know what x is. X is right here. So this time I'm going to plug in this way. You could plug the other way in. It doesn't really matter. You'll get the same answer either way. If you want to plug this one in over here, that totally works. Like I said, it doesn't matter. I usually leave the long one where it's at, and I plug the shorter one in, just because it makes it easier. Okay, I am going to subtract 25t. And then I would get -125 equals -5t. I can divide both sides by -5, and I get t equals 125 divided by 5, which is 25 seconds. I can then take that. I'm going to plug that back up into here, and I get x equals 20 times 25, which is 500 meters. So that does seem like a big number. Does it make sense? It kind of makes sense. Their difference isn't very much, 25 to 20. She's not running that much faster, so it kind of makes sense. It's going to take a long time to catch up to him. So I think we're good. All right, so the last one is the harder one. let's go over it. MOOPS is running at a velocity of 4 meters per second towards MOOPS. Towards MEEPS. MEEPS starts from rest, but accelerates towards MOOPS at negative 3 meters per second squared. That's her acceleration, so that should be a squared. So her A is negative 3 meters per second squared. I know that was a mistake because it says accelerates at negative 3 meters per second squared. So because that's the acceleration. They start 15 meters apart. So I know this distance is 15 meters. And once again, I'm looking for the time and the displacement. All right, I have to write an equation for both. MOOPS is running at a constant velocity, so I can use this equation. MEEPS is accelerating, so I need to use one of the acceleration equations. And I need to use an acceleration equation that has x and t in it, because those are my two unknowns. And so if I have two unknowns, I need two equations with those unknowns in it. So I'm going to use this one. VIT plus 1/2 AT squared. Okay, let me plug my numbers in. I get 4. I don't know this distance, just like the first one. So I'm going to call it x, and I don't know the time, so I call it t. On my right, this is 0. And then we have 1/2 negative 3 t squared. My distance is the distance she goes, which is the leftover distance, which is 15 minus x. That's what's left over. And it's going left, so I gotta make sure it's negative. So the pictures help me because I see left and I make sure it's a negative there. If you don't draw the picture, you might not realize, oh, I need the negative. So the pictures kind of give us this visual cue. Okay, I can simplify this left side by cross multiplying. So I'm going to cross multiply 4t equals x, and the one on the right, I'm going to simplify it as well. I'm going to distribute, and this just goes away. So I get negative 15 plus x equals negative 1.5 t squared, because half of 3 is 1.5, and it's a negative. Okay, two unknowns for both sides. I'm going to take my smaller one, my smaller equation, put it into the bigger one, just to make it easier. Both ways work. Negative 1.5 t squared, and look, we got ourselves a quadratic. All right. I'm going to add 1.5 t squared to both sides. That's going to cancel. And I'm going to get 1.5 t squared plus 4t minus 15 equals 0. That 4 is kind of messy. Let me rewrite that. Plus 4. Okay. The first thing I do for quadratics is I try to solve them by factoring. This one, I don't see it, so I can't do it. My second choice would be to use Desmos and to graph it and find the intercepts. I don't have Desmos on my iPad here, so the tried and true method, the way that always works, you can always use this. Like I said, on the quiz or test, I'd probably plug it into Desmos. You will have Desmos on the quiz or the test. But this is my A, this is my B, this is my C. So I'm going to get the opposite of B plus or minus the square root of B squared minus 4AC. all over 2a. Okay, so I get minus 4 plus or minus the square root of 16 plus, I'm going to multiply all that out. I get 90. And 2 times 1.5 is 3. No, 2 times 1.5 is, 3. Okay. So then I get negative 4 plus or minus 16 plus 90, which is the square root of 106 over 3, which is negative 4 plus or minus 10.30 all over 3. And this will give me 2 answers. Negative 4 plus 10.3 over 3 and negative 4 minus 10.3 over 3. Let's do the left side first. I'm going to just plug it in the calculator. I get 2.1. This is my time, so it's seconds. And on this side, I get negative 4.77 seconds. And I can't have a negative time. It's impossible. It's like going backwards in time. So my answer is 2.1 seconds, and I'm going to plug that way back up here. So my distance would be 4 times my time, and my time I just found was 2.1 seconds. So I'm going to plug that in back up here. 2.1. So I get a distance of 2.1 times 4, it's 8.4 meters. And I always double check my answer. 8.4 meters, does that make sense? Yeah, it's actually a little more than halfway, which makes sense because he's going 4, she's going 3. It's a little more than halfway. Oh, but she's accelerating. But still, it's going to take her time to accelerate up to speed. So it does make sense that he's already moving and she's starting slow and has to speed up. So it does make sense that it's going to be a little more than halfway. All right, hopefully this made sense. Hopefully you understand this a little bit better. If you don't, always feel free to email me. You don't have to come in only during office hours. Come in during break is the best time. I have meetings, club meetings almost every day during lunch. So if you want to ask me a question, emails are great, or you could take a picture of your work and email it to me, and then I can email you back with this is how you would do it. Or come in during break. Before school, after school also works great. And hopefully this cleared things up. I will see you guys in class.